So let's wait a couple of more minutes, then we'll start the session. Because I'm looking only 23 participants. Hope my screen is visible, right? To all of you.
Yes, sir.
So,
Okay, I'm just looking in chat. Somebody have posted some question. Okay, so two families have decided to enter into a alliance by marriage. The first family has 4 sons, and the second family has 4 daughters. To avoid the impropriety, the families insist that each one must marry someone either their own age or one position younger or older. The graph represents this agreeable marriage given below. S1 can marry D1, D2. S2 can marry D1, D2, D3. S3 can marry D2, D3, and D4. How many different acceptable marriage arrangements are possible? My screen is visible. Is that to all of you? And my
sir,
voice is clear also, right? Huh?
sir.
Yes. Yes. Yeah, I'm audible.
Sir, you are audible.
Okay. So this is a second revision session, right? So what were done in the first revision session is a few week 1 to 6 is I think have done, right?
Yes, sir.
In this section we are going to discuss only the calculus portion. Okay. And the next revision session will happen on 31st, and in that we will discuss the graph theory problem. So we'll discuss this question paper is the solution of this one is just arranging, no? So you have to see that if S1 can marry D1 and D2, and D2 can marry and S3 can marry D2 and D3, so that means S1 can marry D3 also. Like this, we have to think, and the other different acceptable marriage we have to count. Sorry.
While counting, it is something initial is 5.
So that's the here like S1 can marry D1. So here is the marriage is given to avoid the impropriety. The family insists that each one must marry someone either their own age or someone one position younger or older. So that means either she can marry same age, or here is the as usual we have, no, either someone one position younger, okay, or older. So either S1 can marry older or maybe younger also, right? Here is both one is written, someone one position younger or older. So as here, so the graph is given. So we using the graph we have to count, like S1 can marry D1. So as there, whatever the possible agreeable marriage is given, here is that like S1 can marry D1 and S1 can marry D2 also. Okay. And S2 can marry D1, D2 and D3. So that means S2 is, we don't know of the same age or maybe younger. So okay, so like S1 can marry D2. So is that possibility that S1 can marry D3?
No, sir.
No, sir.
Sir,
No, sir.
Why it is?
because it is telling about one position younger or older. Here it will be 2.
Yes. So that means here is S1. No, here is not the meaning of. Here's the not meaning of the position. Here is not. Sorry. Yes.
Sir, yesterday this question was discussed, sir.
Okay.
He told that sir told that S1 can marry T1 and S1 can also marry D2, but S1 can marry only one of them. So S1 has a possibility of marrying either of them. So any of them. So one possibility is S1 can marry someone D1 or D2. In the similar way, S2, S3, S4, all of them
Yes.
can marry only one marriage, one
Yes.
wedding.
Yes.
So 1, 2, 3, 4 are possible. He told the answer is 5, but I have doubt in that. So 4 are possible. 4 marriages are possible.
So here is a possibility is asking, no? So that means here
Yes, sir.
here is not exactly the number is asking that he is going to marry with one girl or one daughter. Possibility is asking how many different acceptable marriage arrangements are possible. Arrangement is just asking, not asking that he is going to be like S1 can marry D1 and D2, that's fine. So S1 can marry D3 or D4, that's the question. S2 can marry D1, D2, D3, that's one thing. But S2 can marry D4 or not. Like here is S3.
Actually, my approach was the number of edges are there. So how many number of edges are there? That many marriages are possible. This was my approach, sir. But the answer will be wrong.
Yeah.
And
So
what is this information about one position younger or older, sir? Is it the level of the, I mean, in the graph itself, it's the level that's given, we have to understand that it's younger or older, is it?
yeah, so but it is not given in the question, no, that what is the level? It is not given. It is not given that that S1 is younger than S2, S2 is younger than S3. But one thing we have, either S1 can of this S1 and D1 of the same age, or they are younger or like they are younger one year younger or older than 1 year. This is one information we have. Using that we have to think. Okay, like S1 is of the same age, and like S1 and D1, S2 and D2 of the same age. So either, so see it here, if we are thinking at an older, so here is the marriage is given, S2 can marry D3 here. So they will be of the same age, or they will be of the one year younger, or old greater, or older or younger. So we have to think using that. Okay, we'll discuss how the number of ages marriage is possible. Somebody is posting in chat. So okay, no issue. Let's discuss whatever we have. So in this, I have just taken some problem from the logarithmic and the exponential also. Okay, let's solve this problem. We'll discuss about that and then move on to some problem. We can solve it by using the maximum number of independent set of the vertices formula. Okay. Okay. So please everyone solve this and let me know which option is going to be true. Then we'll discuss the topic. Because week 1 to 6 is already discussed, so this problem is just for notes, and then after solving this problem, we'll start discussing the concepts of 7, 8, and 9. So am I audible? Everyone is solving this one?
Yes, sir.
Okay.
A and B.
A and D. Only 1, 7, 2. To solve this problem, we have to remember, we have to remember the domain of logarithmic function and exponential.
So
And
can
also-
you just give an example of like how to find the inverse of a function?
Yes.
sir.
So using that, we can discuss also how to find it. Okay, so let me discuss this quick because this is a revision session. So, like in the first option, if you see that there are infinitely many polynomials. Okay, somebody supposed to be. Probably the last one who posted the answer that they didn't have thought about this last option. Please think about this last option also. So there are infinitely many polynomials px of degree p. I think some portion is missing for this problem. Of degrees, I think it is erased that. Okay. Let me fix that. This is of 4 degree. So the of degree 4 with this one, there are infinitely many degrees. There are infinitely many polynomials of degree 4, and with the P2 and P3 is 0. We can create, right? We can easily create with the P2 is 0. So this is going to be x minus 2, x minus 3, and then x square, and then multiply with any real number alpha. So if you change alpha, you can get infinitely many, like you just change alpha for any real number, you will get the infinitely many polynomials of degree 4. So easily
Yes,
we
sir.
can do. And the second option is asking the tangent of both x and x square. The
True.
x-axis is the tangent of x square and minus x square. It is going to be the same. Only the one is going to be this side and another one is going to be. You just draw that. Either if you use the concept, you can get that, or maybe in reversal form, you can see. That's why, yeah, many people now posting D also. Now, and the last one, it is given fx is equal to x square plus 1. So how to get that inverse? So if you want to find the inverse, first thing you have to check that the function is 1, 1 or not. Okay, then we can get right the inverse. We can talk about the inverse when the function is going to be 1, 1. So we have to fix some domain, like either it could be of in the positive side 0 to infinity, or in the negative side, then the inverse will exist. So here is any one of the area you can think like on negative side or positive side. So you can think that, and once you assume that, you can assume y is equal to x square plus 1. Okay. Just assume, and you just need to solve for x. That's the problem here. You have to solve with, like here is, you have some equation and you need to solve this problem for x. That's the process to find the inverse of a function. So that means you can write this is y minus 1 is equal to x square, and this is going to be, now take the square root of both sides. So this is going to be x square, or maybe this is going to be x. So this is plus minus x, y minus 1. So now, as only we want one thing, but here is the first thing is that inverse is not going to exist from here itself. We can neglect this option, because here is only one side, is the function is not inversible here. Yeah. So that's why this option is, if you assume this one side 0 to infinity, then in that case the inverse is going to be exist. And now for the domain of this function fx is equal to, we have 1 upon root over mod of x minus x. So once we have a function, we want to find the domains. We have to see the property, like which is under in which, like here we have to think that this should be positive.
Explain question explain option 3, sir. How it is not
Sir,
inverse function?
sir,
Uh-huh.
sir, I just joined now. What are you doing today?
We are joined for the revising the concept of week 7, 8, 9.
This one, sir.
Sorry,
This question, sir.
this question. Sorry, this question is of 5 to 6. Just to think that, okay, the logarithmic or domain property of the whatever we studied
Yes.
for week 5. We quickly, that's why I'm not giving much time here and trying to move on to 7, 8, and 9. So here's this, for the third problem is, again the problem is this function is not inversible. The reason is this function is not 1, 1. Simply you can say The x square plus 1 is going to be like this, right?
Okay, sir, I got it.
Now for the last option, this should be greater than 0, and using that you can start thinking how for which value of x it is going to be greater, or yeah, strictly greater than 0, as it should not be equal to 0 also. In that case, you can think the domain. So okay, so you can draw some log of quadratic or polynomial graph.
Excuse me, sir.
Yes.
Sir, if there would have been a plus sign instead of a minus sign, then it would not be the domain in between minus infinity to 0.
Sorry.
If there would be a plus sign, there
Here
would be
is.
a plus sign instead of a minus sign, then the domain will not be minus infinity to 0.
Here you are saying plus sign, this one.
No, sir. In the equation.
In this equation, this one. No, which?
Yes, sir. Sir, the last option, x mod x minus x.
So in place of what? In place of plus infinity?
Minus sign. In place of minus sign, that would be a plus sign.
If it is there is a plus sign, then the domain will be changed, right? Here is, if it is plus, then it is going to be like, for what value of x it should be greater than 0. That means this is always positive, and here is, this is always positive, but here is the problem, you cannot take the negative values.
Yes, sir.
Like if you think -2, and then this is going to be 2 and -2, so always get 0. So you cannot choose the negative values, but yeah, 0 to infinity is going to be for the case.
Yes, sir, got it.
Okay, so in week 7 and 8, so first thing, let's discuss the concept quickly. So in week 7, we have the we have the sequence of functions. So sequences, and then convergence and divergence, and then limit of the function. In the first week, in the week 7, we have this about the sequences and subsequences, and then limit of function, and the continuity some part is there. Yes. So first thing, what is the sequence again? So as we have discussed in the many sessions, so sequence is nothing but a function. So suppose you have a function fx. Now all of you have done with the function. That function is an expression, or function is a relation with some specific property. Have the relation should satisfy some two conditions. So I am not going to discuss that. But yeah, whatever you have, so in the terms of expression, I'm just telling, if you have some function fx. So here is, we talk about lots. We talk about in the domain of the function. So all of you are aware with the here is that the word is domain. So similarly, if you have a function which will be natural number, or if you are bounding that a function where the inputs are, you will only take the natural number. Okay, like suppose you have a 1 upon x square plus 1. Okay. Suppose this is a function you have. So in case of this one, if you assume here is for any real number, you can put here and you will get the output. But suppose your input is only the natural number, so this function can be treated as a sequence. So if in place of x, you can write this generally for fx is equal to, or fn. You can think this is going to be fn, and this is n square plus 1. You can think here n is a natural number. So this is, now you see that this have been changed in the form of sequence. So sequence is nothing but a function, but its domain is fixed, which is a natural number. But output, which is a codomain, can be anything. It could be real and integers or anything, some subset of real number you can think. So once you have a sequence, so there is a one condition that so once you have a sequence, so why we needed why we are studying these sequences? We are just breaking down the, like if you want to study this property of this function, we are trying to break down this. Suppose there is a difficulty or a very big expression is written, the function in the very big expression is written. So you want to try to know the behavior of function, how, what will be in the case of very large values, or what is going to be some particular point if you are approaching. So what is going to be with that? So for that purpose, we are going to, so you can break your function or the domain of the function in the some subset of real number, which you can think of the natural number. And also there is one reason to study on the sequences is we know that the counting number, natural numbers are the counting number. So very easy to study on the counting number in place of in place of real number, like real numbers contain rational number also, irrational number also. So it will be difficult to study on the irrational number, but it will be easier to study on the counting number, that is the natural number. Once you study that, then suppose you studied the property between two natural number, that okay, the output is going to be this one. So in between anyhow the output is going to be very similar to this point. So that's the purpose to study the natural number also on the sequences also. You are changing, you are breaking your problem in some part of the domain which is on the natural number, and then you start now. So once you have the sequences, so what is going to be the case when your input? So here is will be more focused on where input is going to be very large number. What is going to be in the behavior, as all of you studied in the behavior of polynomial. So what is the case going to happen when you are trying to give the very large input, very large number as an input? What is going to be the behavior? So there in polynomials, you studied only some smooth on the polynomial, but here we are going to study of any kind of function. Either it could be trigonometric or rational functions or any kind of function. So what is going to be the in behavior in the case of when you are going to substitute very large number?
Sir, are you writing something? Because
No, I'm just explaining. No, nothing. I'm not writing. I'm just telling.
Okay.
So here is, in that case, what is going to be? So once you have this one, okay. So once you give, here is, that's the meaning here, as n goes to infinity, this means that you are trying to find the limit. This means that you are giving a large, this you once you have this sign, you can think that you are going to input, you are trying to give the input as a very large number. You are approaching to infinity, that's the meaning here. So limit as n goes to infinity, what is going to be with this function or this sequence? Is that output is going to be with the, so here is one problem, that is that output is going to be some fixed number or going to be infinite, or it is just varying. It is going to be varying. So we want to know, is that happening something? So is that any real number? If it is a real number, that the outputs here is, means you are giving the very large input, the output is actually coming around a fixed real number, or still it is also approaching to infinity, or it is actually, or it is just sometime it give -1, 1 or 2 or 3 like this. Is there any fixed number that it is around that you are getting, or it is going to also give the infinite, or it is some oscillating some between some number? So if it is approaching to a fixed real number, then it is convergent, then it is called convergent. If it is oscillating some number, then it is the sequence called oscillating. And if it is also approaching to 0, then it is called divergent. There are 3 cases, but we will more focus on try to find the, so generally there is a problem that if you have a sequence, then what is going to be the limit of the sequence?
So what is the meaning of oscillating?
Oscillating means you can think for the case of here, like let me write it here. Suppose you have a sequence fn such that -1 to the power n, when n is when n is 3 into n, like n is a multiple of 3n, and here is 1 when n is multiple of 4. You can think like this. Is this 2 or classing? Yes, it is. These two are or multiple of 5. Number it is going to be classing, or either to be even or odd. Some either is simply the simple cases or sine function, sine or -1 to the power n. If you give the input, it will give sometime 1 or it will give -1. You will give either 1 or -1. If you substitute any large number, it will give either 1 or -1. So between two number, the outputs you are getting, not a fixed number, like for the case of this one. So what is going to be the output when you give the very large input? That means what is the limit of the sequence? That's the meaning. So what is going to be the limit of this sequence?
0.
0, sir.
So it is going to be 0. So generally the meaning of, there is a simple meaning of it, that this just give here very large input. So this is going to be also very large number, and 1 upon very large number is actually very large number is going to be. So also you can large number that is not fixed, so you can think it as an infinite. This infinite sign means very large number. Okay. It is not fixing, but yeah, we know that. I don't know what is the number, but yeah, we know that it is going to be very, very large number. So in that case, the output is going to be very, very small number. So that sign is actually written as approaching to 0. There is limit as n goes to infinity, the limit is 0. So please everyone solve this problem. I'm just writing a sequence. What is going to be here, which is n square plus 2n upon 3n square plus 5n plus 1 plus sine 1 upon n. Please everyone solve this problem. What is sine n?
The sine n.
Yes, sine n. So what is going to be that? Is that exist? First problem is, if exist, what is limit? And not exist. I'm just looking, somebody is posting the answer. Let's see what will be the answer here.
So today from which weeks will you be discussing?
We will try to cover calculus portion in this week. Sorry, in this session. Manish, Ansika, yeah, Prince, Siddharth, yes. Richa. Yes, somebody want to say something? This will have posted the answer.
X squared plus 2x, right?
Sorry, x square, not x square. Sorry, this is n square plus 2n. This is 3 by n square plus 5n plus 1.
Oh.
4 by n, 4 by n. And once you find the limit, then find suppose this is a sequence an. So what is going to be the limit of the sequence, or what is the find the limit as n goes to infinity? E power an and log of an. We have two sequences. What is going to be the limit of this sequence of both e power an and log an? E power 1 by 3 and log 1 by 3. Yeah, so that's the property. Okay, so let's discuss this one. So what is going to be limit? Limit is again, so limit property that if you have this one, okay, if you have this one and both limit exist, so in that case you can make the separation of the limit. So that means here is you can make limit as n goes to infinity this one plus limit and goes to infinity this one. So what is going to be the limit of this one? So this is n square plus 2n upon 3n square plus 5n plus 1. So to find the limit here, you can divide numerator or denominator with n square. So directly I'm just writing here, you can write this is 1 plus 2 by n upon this is 3 plus 5 by n plus 1 by n square. Okay, now if you take the limit as n goes to infinity, separately you can think this is going to be 0. The reason is 2 by n is actually, again, this is a very large number and divide with the only, and you are dividing 2 with the very large number, it will approach to 0. So that means this goes to 0, this goes to 0, this goes to 0. That is finally 1 by n. Sorry, 1 by 3. This will approach to 1 by 3. What is going to be with this one? Sin n. Sin n by n.
It will be equal to 1. 1.
It will be 0.
It will be equal to 1. 1.
No. Why it is 1? Why it is 0?
Sir, because sign will vary between 1 and -1 and n will go to infinity. So the whole number will go to infinity.
Yeah,
I mean 0.
So there is one, sandwich theorem. Sandwich theorem will help you to find the sequence limit of this sequence. Okay, we know that the sign value is maximum sign value is 1. Okay, we know that sign value can vary this one between -1 and 1. So just divide with both sides. Just divide in this inequality with 1 by n. That means wherever, now sandwich theorem, sandwich theorem is what? If you have sequence an and if you have sequence bn, and between you have a sequence cn. Okay, and the sequence is approaching to a and this sequence is also approaching to a. So sandwich says this should also approach to a. This is the sandwich theorem. So here is again using the sandwich theorem, you can think, okay, this sequence is approaching to 0 because this is -1 by n and this is approaching to 0. So this sequence will approach to 0. This is the use of sandwich theorem. Okay. And once you have this one, so what is going to be the limit of this sequence? The limit of this sequence is going to be, once you have a sequence an which is approaches to a, then e power an will approach to e power a, that limit where an approaches. And if you have log cn, which is where cn approaching to positive, it should approach to the positive value. So if it is approaching to positive, as we have already counted that, it is approaching to 1 by 3. So that means that our sequences. So finally, the whole sequences, I forgot to tell you, the whole sequences will approach to 1 by 3 plus 0, which is 1 by 3. Okay. So limit of this sequence is going to be 1 by 3.
Can you just explain sandwich theorem?
Sorry, which one?
The sandwich theorem of minus and minus.
Sandwich theorem is, that's the say here I'm saying, if you have a sequence, 3 sequences, an, bn and cn with this condition. Okay, with this condition, if you have 3 sequences with this condition, okay, for all n belongs to natural number or for all n some fixed number. After some fixed number, this is this the sequences is following this one. Okay, this condition should hold. If this condition is holding, then if this left one is approaching to A, right one is also approaching to the same limit A and A, then finally we don't know the sequence where it's approached, but if it is following this condition, then it will definitely will give the limit. That is the sandwich theorem.
So what will be the limit of psi n by n when n tends to 0?
There is no meaning of the sin n goes to 0, right? Sin n goes to 0 means what? That is the case for sine function, sin x by x. What is the meaning of sin n goes to 0? What is n here you are taking? Variable for real number or for natural number? Many people, I have listened many such problems that as what will happen when n goes to 0? What is the meaning of n goes to 0? Can you tell me what is the meaning of n goes to 0?
Undefined or natural number cannot be 0.
1 by n tends to infinity.
Yeah, here is not meaning because sequence is generally limit. That's the here I said, right? What is the case will happen when n goes to infinity? Only in that case we are defined convergent, divergent, oscillating. Not for n goes to 0. There is no meaning to say n goes to 0 means what? We are at n goes to 0, not the variable case for any real number. In that case, x goes to 0. We are generally think about this one. So there is no meaning of n goes to 0. What it means that n is actually a fixed number, and we are actually starting from 1. The natural number we are counting from 1. If you have studied in the calculus, generally will not consider the. Already you are in the maths one. In the week 1 said sir, natural number contains 0. Calculus sir said will not consider the 0 in natural number. That is not a big deal because sir is just starting from 0 and calculus portion sir is starting from 1. That's the meaning here. That is not a big issue. But yeah, there is no meaning of saying to be n goes to 0. What it means that here you are approaching to from infinity to 0. Then sequence will not be sequence. We know yes, what is the sequence means. We are trying to analyze the terms. So what are going to be the outputs related to that when the case when you are going to be discuss very large input. Okay. So here is yes again.
Excuse me, sir.
Yes.
Sir, in the beginning of the question, you asked that if this kind of sequence can exist or not. So, sir, is there some way to know if a particular kind of sequence can exist or the other kind cannot? Sir, like you asked in the beginning.
No, exist means sequence not exist. Limit I am saying limit will exist or not. Not sequence. I am saying limit will exist or not. If it is exist, then what is going to be that?
Okay, sir.
Okay. So here is I am just looking what is the I have seen some so somebody is saying what is in the case of limit and goes to infinity e power a. So whatever the color I am using, is that fine to all of you or need to change? Just bad. Let me change it with the black.
It's fine, sir.
It is good, right?
Black.
Please, Cyprian, mute yourself. Okay. Thank you. Okay. So here is if in the exponential case, this means this will approach to e power a. Sorry, e power a, that limit where an approaches to a. And the case of log of an, if you have, then this will approach to log of a. Okay. So please, everyone, go through with the solve with the assignment. No, there is properly written the formulas. Even sandwich theorem is also written there. Every formula is written there. Using that, you can think where it will approach. So directly you can think this is going to be e power 1 by 3. So our sequence will approach to here. This limit is actually, where is that? Yeah, this one. This will approach to e power 1 by 3 and this will approach to log of 1 by 3. Okay, so this is, I think, okay, this is This is the, I think, only for we say regarding the sequences and subsequences.
Sir,
Uh-huh.
sorry to interrupt. If possible, could you revise faster, sir, so that like more
Sorry,
things.
sorry.
So if possible,
Sorry.
could you revise faster, sir, because more things can be covered. Because
Yes,
it's a
yes, it
revision
will.
session.
Yeah, so now we are going to discuss with the limit thing. Now, once you have deal with the limit of sequences, so now the limit of function. So that's why next part is I'm going to discuss. Yeah, so sin n by n is going to be 0 limit. So just now I'm discussing. This is going to be 0. And the chat somebody is asking. Okay, so now limit of function. So again, the same word, nothing is going to be changed. Here is limit of sequence means we are going, what is going to be happen with when n is going to be very large number. What is going to be output? Is there any fixed number where around that you will get the same what is there? Nothing is changed. Nothing have changed here with the same term that if you have a function, okay, if you have function and again the word limit as x goes to, or even the wording x goes to a, what it mean that? It means that x goes to a means you are thinking about, suppose here is a, here is a, so x goes to a means you are thinking about the input as an input, or you are talking about the real number which is around a. That's the meaning. Either it could be from left side or right side. So this means that you are talking about the real number which is around 2a. Okay, this around 2a, not a, exactly not a. It is around 2a. That's the meaning here. This is not exactly a. This means that you are talking about the real number around it. Okay. And if it is this, then if this, what it mean by this sign is x approaching to a. This means that, and here is fx is there. So this means that here this sign is actually, just a minute. Okay, yeah, I will upload this in portal. Okay, so here is, so this means that here is limit with this sign means this tells you that what is going to be bound of that. So here is, if you are giving the input, suppose the output is, suppose this is the graph of the function. So output is that you are giving the input here. So is there any fixed number, or is there any number around that you are getting the output, or it is going to be infinite, or it is like this? Around a, you are giving the input, it is going to be like this, or it is going to be, sometime it give here and sometime it will give here, like this the outputs are. Around left side is going to be this one, right side out. If you are giving the input around that, the left side input is, the output you are getting this side, and left side you are giving the input, the output you are getting here. So 3 cases I just wrote, right? Either this case, or it is going to be infinite, or it is, there is a fixed number around that it keeps it, you are getting the output. Is it clear what I am talking here? 3 cases I just wrote.
Yes, sir.
Okay, so that's the meaning here, limit. That's the meaning here, this word. Okay, once you have this one, so this case that, yeah, limit exists. Okay, yes. Uh-huh. Yes.
If it is approaching from right side,
Mm-hmm.
it is going near to that A from near to the point near to A from the right side,
Mm-hmm.
and approaching from left side going to the near to that point around A.
Uh-huh.
And if neither of the cases, then it is going to infinity.
So there, sir, that's the here, sir. If you are left side, still it is kind of asymptote is happening. Left side, also right side, also kind of asymptote is happening. So three cases, that's why I wrote. It is kind of this one, or if you are approaching from right side, it give approaching to here. The outputs is actually coming to a fixed number, but it is here from the left side is here. Sorry, from the right side here, and from the left side some another number, and around that you are getting the output. So three cases I just wrote. So here in this case, you will say limit exists. In this case, you will not say limit. This is also not limit exists. Limit not exist. And here is also. So here is this one is called left limit. Okay. And this one is called right limit. Okay. This is called left limit and this is called right limit. Okay. And if left and right, see that if left and right are both same, like here this one, then you will say limit exists. And if they are different, then you will not say. So in this case also limit not exist. If left and right are same, that means this case will happen. And if this case happen, then only the limit exists. And rest to both cases limit not exist. So that's the meaning, exactly the left limit, right limit, and this. And this is all about, that's all. The limit is done. And now let's solve some problem related to that. This is a limit case, is week 7 is finished. If you are understanding this one, limit is done. I hope now it will clear. It is clear to you that sorry.
Sir, clear.
This once again, sir, confused in the middle, sir.
This middle one, this one.
Yes, sir. Yes, sir.
So this case you can think like 1 by x. 1 by x. Can you think with this function? Can you think with this function? Suppose you are 0, you are giving input here, this side, this side. What will happen with this function? It is kind of infinite, right? This is kind of this one and either this one.
Yes, sir.
This one and this one. Or sometime if you have it is mod of x, in that case it is like this, right? So this that's the same case I wrote. So in that case again the limit is not exist.
Okay, sir.
Okay, got it? So here is
Yes,
if you are getting this all three, that's the limit is done. That part is that. Now let's solve from problem. So I have one problem. This one. So let me tell you the continuity. That part is, what is the continuity? Continuity is nothing but if limit exists, okay? If limit exists and it is equal to the function value of the function, equal to value of the function, then function is continuous. If it is value of the function, then function is called continuous. That's all. So that the continuity will part we'll see with an example. It will be more clear to you as I have one problem based on this. So this one. Okay, this problem. Let's solve this problem. Or even not this one, or this one would be better. Okay. So here is, let's talk about the, here I'm just writing here. This problem with adding one question is here. Okay. So find the limit. Okay, this problem, please on this problem, limit as x approaching to 2, x approaching to 4 in these two cases, and is function is continuous at 2 or 4. This is the problem. This is the function you have, and this is the problem. Now tell me what is going to be happen. This problem we'll see later once we deal with the Riemann and differentiabilities. And this is the same problem, but talking about. So please everyone solve this problem. Limit exists at 2, 4, and can you tell me the continuity with the same function as here?
Not continuous at 2.
Not continuous. Okay. We'll see it. Okay. Anyone else? Yeah, please, if you want to solve this one.
Not continuous, sir.
Where it is not 2 and 4 or both?
Both.
Both. Okay. So not continuous, the case is for not existence of limit, the case is, or the function values differ with the limit case, limit value.
Exists,
Not
but the
exist.
limits are different. I got existence of limits, but does not exist. I mean, like not continuous.
Function value is not equal to limit value.
Actually, even limit does not exist.
Left hand limit and right hand limit are not equal, so limit does not.
Left and right are not equal. So that's my case.
Okay, so let's see that. So let's solve this problem. So okay, so let's find the limit as x approaching to 2 in that case. So we have two cases. We are approaching to 2 means here again, here is supposed to, so by this way or this way, we have to check. So so this could be written, left is generally written as 2 power minus. This tells you that you are approaching to 2 from negative side. Here is from minus side. Okay, so this is, so what is going to be this function is from the negative side, means lesser than 2. That means this, that means here, which is x square plus 6. Now here is a simple polynomial. That means just need to substitute here the value 2. That's the meaning here. Like approaching means you can easily substitute the value here. So here is, this is going to be 4 plus 6, which is 10. Let's count for the, okay, here is 2. Okay, so let's count for right. So this is called left limit, and right limit is the notation is limit x approaching to, not this. This is the right, means 2 power plus sign, 2 to the power plus sign. Here is, so 2 to the power plus sign is, means the values is actually greater than 2 but approaching to 2. So this is going to be, this is the function. There is 2 times. So again, this is a simple polynomial. That means you just need to substitute here. So let's substitute here. So this is going to be 2. If you substitute here, this is going to be 0, and this is 6. So finally, the 6 is there. So let's see that the left limit, which is, we have 10, and right limit is 6. So which case is happening here? This one, right? This one. In that case, limit is not exist at 2. My voice is clear?
Yes, sir.
Okay. Oh, so this is one thing. So at 2, I just feel I'm just leaving the part for 4. Okay, I just leaving for you 2 at 4. Easily can be done. Left side is with this one, right side is with this one. Okay. So again, easily we can check. Here is left side at 4 is actually give some number, and right side will give number. I'm just leaving for the 4. 2 we check that. And also, if left is not equal, left limit is not equal to right limit, then in that case, limit is not exist. If the limit is not exist, then continuity will never happen, because continuity says the limit should equal to. But here is the, even the limit not exist. How we can talk about the continuity? So that means function is not continuous. Okay. Yes.
Can you take one question on this topic only from activity?
Yeah. Sorry. Yeah. Somebody else is saying. Yeah. Okay. Someone else is saying yes.
I want to understand how you selected the polynomials for left hand limit and right.
Here is left and right, means here is, you can see from here. No, we are talking about 2. Our 2 is here, and what is about this says? This says what? That means your x value is lesser than 2, right?
Yes.
And lesser than 2, how the function is behaving? This one.
Okay.
That's the process. When x is greater than 2 means this one, and how the function is behaving?
Like
this one.
Okay. Okay. Thank you.
Okay. Okay. And the activity problem is very similar to like this only, no? Either see,
I have one
maybe.
in 7.5 question 11.
Sorry.
The 7.5 question 11.
So can we? Okay, let me finish this one because my part will be break. Like I will unable to finish on time, so it will be difficult. But yeah, I think so. It will be very similar. Or maybe see, this problem could be asked differently also. Let me make this one is
It was a
clear to you. Sorry.
Sir,
problem related to graph.
Yeah, it could be in the graph portion. We can see it in the graphically. Okay. We can see it. So this problem could be differently seen. So here is by this way we can think. Okay. So suppose this is a function is given and the graph of the function is like this. Suppose so it will be differently asked like this, like x square plus 6 is given, so that means left side of 2. So here is 2. Suppose here is 2, then at 2 value is left side is approaching to 10. So that means like this it will be. Okay, and here will be open ball. Here is the whole circle will be, and here is, and right side is x cube plus 3. So at 2 it gives 6. So here is, then here will be 6 here, then it will be like this. It is will be solid, and when it is 4, and here is 4, suppose when it is 4 around that, so here is actually like this. Here will be hollow. Here is okay. So here is 4, and then when it is greater than, then x plus 1, like this. So similar the graph problem. Suppose this is, now you can think you can erase this one, and then problem is asked like this. Okay, and here it will be solid. Solid means here is solid means the function output is actually getting here. This is 1. This is 6. Oh, sorry. This is 6. This is 6 and this is 10. Okay. So here is the graph. This problem could be asked like this also. Okay. Very similar problem, even with the graph. And now the problem will be the same. What will happen at 2? What will happen 4? What is this continuous, or it is anything else? Continuous differentiability, find the integration in the portion, in this portion, or in this portion. But yeah, this is the same problem, exactly the same problem. Here it is written in the algebraic form, and here is the graphical representation. Okay. Okay, so this is the limit part. Now next is limit and continuity. We are done. So now the next is the differentiability. In differentiability also we can, am I audible and voice is clear? I am going fast or slow, or it is okay, or what I am discussing, is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Sir, in the previous diagram, one doubt. In 2, the function is continuous, right?
At 2, it is not continuous, no?
So
We
can you
just
just
now,
pull up?
here is we verified, no?
No, sir, but from the graph.
Even the graph also at 2, it is not continuous, no?
Why, sir? Because okay, sir. Okay.
Okay.
Yes, sir.
And let's talk about the differentiability. So differentiability. So many people have doubted what is the meaning. What is the meaning of the word differentiability, differentiable, and derivative? So let me first clear that what is the differentiability. Differentiable and differentiability with the same meaning. Derivative is the different thing. Differentiability means if you have a function fx And the question will be asked like that. Like suppose if you have given this function and a point is here A, okay, and you have given a point A. Is this function is differentiable at A? This is the problem. And derivative means if you have a given function with some expression, okay, and the derivative means here you have to find the derivate function. Means once derivate this one, and all of you are aware with the derivative of x to the power n is actually n in times x to the power n minus 1. Sine is actually sine x is cos x is sine x with the minus is here, and e power x is e power x log of or here is the many ln x is 1 by x log of or a power x is what is a power x? A power x is log of
Power x
log e or a. This is a similar kind of thing, or it is of in the multiplication. Something is there. I think it is in the multiplication. Please check with this one, okay? And
yes, somebody.
And okay, and then after if it is in the form log with a base a and x, so that means here is 1 by x and then 1 upon log a, or sorry, a, this one, I think so. So these are something, and then after the constant is actually the derivative of constant is 0. So just remember this one, okay? Please remember this, at least these all, whatever the simple one, okay? Tan is some have tan have something, okay? So this is called the derivative, so here is this is the mean of derivative. So these functions are derivative of this one is this one, derivative of this one is this one, derivative of this one is this one. So actually derivative means these all functions are differentiable for all real number, for any real number simply. So this whatever the function I just wrote, these functions are actually differentiable for any real number, and the derivative is this one. And here is actually we are checking if the function is differentiable at that point or not. So this is the difference between derivative and differentiable. Now, what is why we needed this one? So simply in the by two ways we have to think. So see, all of you have gone through with the coordinate system. So there is a slope thing, slope with the line. So this is a simple line, okay? This is a simple line, and you want to find the slope of this line. What will happen when in place of this line you have a curve? Okay? You have a curve.
Tangent will be the slope.
So suppose you have here is you have a line, and then in that case you are trying to find the slope. What will happen? Your line is actually this, in place of line you want to find the slope of a function, which is it is not line, it is a kind of different thing. It could be polynomial, quadratic, or sine, cos, tan, trigonometric function, or rational function. Rational function is the kind of p by q form. Here is the meaning of p by q form, that is called rational function. Anything. So here is either this one. So what is going to be the slope at here? So here is for a line the slope is fixed, right? Here you know that for a line slope is fixed, but here it is not line, here is curve. So what is going to be the slope for this curve? So for each time it will change. For each time it will change. For each time it will change. So that's the here derivative. Derivative is actually if you, for suppose at a, you give value a here, at a what is going to be the derivatives here? and so it is going to be a power n. A power n, the function is going to be a power n, and the derivative is going to be n times a power n minus 1. That means slope will be slope at a. Suppose here is a, and the graph of this one is this one. So at a, the slope will be this one, n times a power n minus 1. Here is, suppose this is b, then this is b into b power n minus 2. So see that the slope is actually changing here. So derivative gives the actually slope with respect to variable. Here, like here is derivative, you are getting the x form. No? So actually slope is also, that's the meaning here, slope is changing. So here is the slope you are getting. So what is the slope means here? Slope of the curve of this one means slope of the tangent line which touches here. The same slope, what is there? But this slope is, slope of this curve means here, a line which touches the curve at here. What is going to be the slope of that line? Okay, that's the meaning here, slope of that curve. Okay. If this line touches this curve here, okay, and we know the slope of that curve, that line, that slope of that line is nothing but this one. Either if the curve is touching this one here, so that means this is going to be slope. That means here is tan, if it is theta is here, so tan theta is n times a power n minus 1, this slope. This is the meaning. This is the derivative, use of derivative. And I hope all of you got that what is going to be here. And the formula of generating is the same. Let me write that as the slope case for the line. For the slope case of the line is the what? Suppose this is y2, sorry, this is x2, y2. So what is the x2, y2 means? Here the input you are getting, giving x2, and output is getting y2. Here is x1, then here is the point is x1, y1. Okay, what is the slope here? Slope formula y2 minus y1 upon x2 minus x1. The same case here. So this is very similar case with this curve also. Okay. Here is, this is the input. Let's say this is alpha. So you will get f of alpha. So that means this point is alpha f of alpha. And suppose I just here is, let's say alpha plus h. Small increment is there. So output is going to be f of alpha plus h, right? The same thing happened similarly, very similar, same thing. So this point is going to be f of alpha plus h, sorry, alpha plus h and f of alpha plus h. So same thing as here, the same formula, we can take it here. So this is alpha, sorry, f of alpha plus h minus f of alpha, the same. Sorry, this y2 minus y1 or y2 minus y1 upon x2 alpha plus h minus x1, which is alpha. Alpha will be cancelled out. So finally, f of alpha plus h minus f of alpha upon h. Okay. Now this is we have. Now here we are, actually we don't know. Here is, see, this is a big distance is here. Okay, see that this is a big distance. What will happen? And actually, see, if you accurate this one, this is not correct because every time it is actually changing. This is not line, this is a curve kind of. So we have to h very small. So h very small means, just now I said, no, h or x goes to approaching a means we are talking about around a, very close to a. So here is, we want to be h very small means that sign is nothing but h goes to 0. This is the meaning. H is very small means h approaching to 0. This is the sign representing, this is the representation. This is the representation of h goes, or h is very small. So that's the meaning here. Now you can put it here. H goes to 0. What is this fraction? What is this fraction? Here is, that's here slope. Is this clear how to generate, or what is the meaning, or what is the here derivative thing? Is this clear?
Yes.
Yes, sir.
Okay, this is the meaning of, this is the slope meaning. And if this limit, now the same problem will arise, no? Limit exists, not exist, infinite. The same problem now, this change. Now we have changed this problem in the variable h. This is a variable. It is a kind of variable now. But now the same problem. Left limit, right limit, infinite, not exist. Like this, very similar to this one. Now the same problem is arise because now we are on the limit case. Now here is there is left limit, right limits. Here is also same case will arise, no? Because you are approaching to 0, means here is very small number. That means here is suppose 0. So by this way or this way, we have two ways to approach to it. So here if it is left side, okay, then it's called left derivative. And if it is from right side, that is called right derivative. With the
So,
same.
sir, what is alpha and h, sir? Like, can you just explain it again? The graph which you have drawn.
Okay, just a minute.
I know how to solve, sir, but probably the concept I'm not clear.
Sorry. No, here is alpha. Here is alpha means here any real number. No, here is alpha means here you can think 5. Any real number, 5, 10, 12, anything. So here is alpha means any real number. So almost we have done, no? So we almost the derivative thing is finished, then everything is done now. Only the critical is remain and integration. So we are on the same page.
Sir, you said we
Correct.
can find a left-hand derivative and right-hand derivative.
Yes, yes. So here is left-hand derivative limit h approaching to. Here is the same sign. This is the sign of left side you are approaching. F of alpha plus h upon h. The right side is.
So this is only a Riemann sum, no?
Yeah, till Riemann sum we are going to discuss in this session. Because that's the ending of means or finding the.
Sir, both are same, isn't it? Left-hand derivative and right-hand derivative formula.
So here is the only this one is changing, no? The formula is same change. So everything is same. Here is the change. Here is the change. Here is this one. Means here you are giving like now this will very much clear. Now we will solve problem. We'll see. Okay, we'll see. So this is done. The derivative part is done. Okay. And one thing is remain here is indeterminate form and the L'Hopital group. That's the part here. So we'll discuss that. Let's solve a problem. The same problem. It will be more clear to you when we will solve this problem.
So what are the topics we will be discussing today?
So today till Riemann we are going to discuss. So
Yes,
only
sir,
we
so
have.
what will be the other topics?
Sorry.
Sir, no, sir, what will be the other topics?
So
after-
other topic is just critical point, maxima, minima. Okay. And we will solve problem related to that and the Riemann and the area under the means integration. So only
Yes.
2-3 topics is remain now. Because once the differentiability is done, then indeterminate form is very small time. It will not take much time. And maybe we'll see some problem there. And then move on to the critical point and maximum minimum.
Excuse me, sir.
Yes.
Sir, we are only taught Riemann sum of like mid and left and right Riemann sum, right, sir? Not like the trapezoid one. So like I found a question where I was asked to find the interval, find the area using Riemann sum and like the trapezoid form.
And trapezium.
So does that mean middle points or like is it not in the syllabus, sir, like the trapezium or
No,
trapezoid?
so trapezium is also in the syllabus. No, trapezium is nothing but you are taking the area. You are taking the area in between like mid of that. Left sum,
it's
Riemann sum, and taking the midpoint of.
Oh, so trapezoid. Whenever I see trapezoid, it's just the midpoint, sir.
Yeah, that's the mid. That nothing but that is the midpoint.
Oh, all right, sir. Understood, sir. Thank you, sir.
So how to find the left hand derivative and right derivative? So yeah, so let's solve problem. So I am taking the same problem here. Okay, and let's check with the derivative. Okay, this is the same is here. So here is the same problem we have. Okay, please everyone check the differentiability of at 2 and at 4. Oh, so here is already we have discussed. No, it is not continuous. Limit is not exist, not continuous. Then it is not differentiable. Let me take the another. This one. Okay, this one. This problem. Now this problem we are going to solve.
Sir, for a function to be differentiable, it must be continuous at that point.
Yes.
So can we take it in other way? Like if the function is continuous, that means it is differentiable?
No, no, no. If it is continuous, not necessary, it is differentiable.
Not every continuous is a differentiable function.
Yes, yes, yes.
Okay.
So here is, let's solve the problem for this one. For what value of r, the function is going to be differentiable everywhere. Everywhere is asking. Okay, somebody is supposed to do in the say. Okay. R is going to be 2. Please, if you solve this one, I will ask to the reason how we are getting that R is 2, P is 6, or okay, we'll see. Or by this way, let's solve. Let me finish myself. How it will find, what is the meaning of it. Okay. So let me solve this problem even for the differentiability case for this problem. Okay, so here is f is differentiable everywhere means, see, the problem for the function is only at 0 or around 0, not around exactly at 0. Less than 0 is this function. At 0 is this function. Greater than 0 is this function. We have 3 cases. Okay. And we want to check that for what value of r it is going to be differentiable everywhere. If it is less than 0, that means you have this here is left side is this function. So left side is this function, and this is what? This is a simple function, exponential function with some linear function is there. The combination of exponential and linear. So can you tell me, is this differentiable? Is this function is differentiable when x is less than 0? Can we say?
Yes, sir, we can say.
Why?
Sir, because we can find the derivative of this function. Limit exists. In the question, it is said that limit exists at 0. So that means it is continuous.
Oh, yes. Okay. So here is left side is differentiable. The simple reason I am just asking the reason because you have this function, okay, and this is the left side. Okay, this is the left side. So this is a simple problem, like it is exponential. We have already, we know the e power x, if you differentiate, you will get e power x. This is a simple linear function, or even you can think this is a linear function. So you can differentiate easily 4x going to be and then plus 3, or this is finally it is going to be the derivative is going to be e power x minus 4 p time, right? P time e power x minus 4. Function is differentiable for the right when x is greater than 0. Everywhere when the value is greater than 0, the function
Yes,
we
sir.
having like this. So is this differentiable?
Yes, sir, differentiable.
It is also differentiable because we have sine function. No? Derivative sine is everywhere is differentiable. So sine is if you do that derivative of this, when x is greater than
Explain
0.
the first and the second question again. I had a network.
Sorry?
So can you just explain the questions again? I had a network issue.
So this is the problem. F is differentiable or not. Find the value of r where so that the function is differentiable everywhere.
So I did not get why the first equation is differential. Can you say it again?
This one. This one. You're saying why this is?
Yes, sir. P to the power x minus 4x plus 3.
So p time e power x is this differentiable? So the problem is e power x function is differentiable or not. That means you have to check with the limit e power x, h goes to 0, e power. That means the same definition you can use. No? So actually e power x is a differentiable function. Either by this way, I just now I wrote because the derivative of e power x is this one. So e power x, sine function, cos function, x to the power n function, log function, exponential a power x function, all are actually differentiable function. You can verify easily with the limit of this, with the definition by this of the definition by this definition. Okay, we can easily verify. So this actually by this way you can say this is differentiable. This is the same x to the power n case where n is actually 1. So that's why this is also differentiable. This is constant. So that's why it is differentiable. Okay.
Okay, sir.
And left side is again the sine function is a very smooth function. And also we have by this way again you can check with the here is sine is derivative is cos, cos is sine, minus sine. So by this way you can say this is differentiable, this is differentiable when x is greater than 0. But the problem is only at 0. So everywhere is differentiable means we have to only check at 0. So let's check that. So let's check with the differentiability. Differentiable at 0 we have to check. So what is the same? Then they use the definition limit. H goes to 0. Here is our alpha is now 0. Our alpha is our 0. The same definition we can apply here. That means here 0 plus h minus f of 0 upon h. That means finally limit h goes to 0. F of 0 plus h going to be h minus f of 0 is going to be f of 0 and this is h. Now we have to check with the left derivative and right derivative. First here is approaching to 0. So left derivative, which is limit h going to 0, this one. H plus minus f of 0 upon h. So for the left side means here is lesser than 0. This is the mean of lesser than 0. H is lesser than 0. What is the lesser than case? When h is lesser than 0.
The question is to find whether the function is differentiable at 0.
That's the problem here. We are checking actually if the function is differentiable or not. So when h is less than 0 means here is function value when how the function is behaving when the value or input value is lesser than 0. We having like this one, right? That means here is going to be p time e power in place of x, just h will be there minus 4h plus 3. Function value at 0, function value at 0 is q minus h. Sorry, q minus 5 and upon h. Okay. Q minus 5. So here is in bracket it will be. So here this will be, this is fine. So finally you have p time e power h minus, this is 4h minus q, and this is going to be minus plus 8 upon h. So we don't know what is p and q. Okay, we don't know what is p and q. So okay, for the time being, I'm just changing here. Okay, I'm just changing it here with the
Sir, we can first find the value of p by
Before that,
since it is given
we
that
have to
limit
find the
existed.
p and q. First find the value of pq, which is a head problem. So here is says limit is, so let's find first. So let's find the p value and q value. So again, the limit is says limit at 0 is exist. So limit at 0 exist means let's find the limit at 0, limit as x approaching to 0. What is the limit here? So here is limit exists means left limit and right limit same. So left limit is going to be what? Can you tell me quickly? And everybody can tell what is going to be left
p
limit?
plus 3 left limit.
It is going to be just needs to substitute. Here is the when x is approaching to 0 means the function is from the left limit. So here is left limit if you think this is going to be this function we have like this, and you just substitute here value 0. That means here it is going to p e power 0, which is going to be 1 minus 4 times 0, 4 and plus 3. So left limit is going to be this one, and
p plus 3.
Right limit is this one. When x is greater than 0 means we have function we having like this. So this is going to be this one. So so here is going to be what?
The left hand limit would be p plus 3 and the right hand limit would be 9.
So here is p plus 3. Here is p plus 3. Okay. So here is r time 0, sine value sine 0 at 0 is 0, and plus 9 cos 0 is 1. So here is finally 9. That means here p is going to be, now let's solve this one. This left limit is equal to right limit. So it is going to be p equal to 6. So here is actually 6. So 6 times e power x minus 4x plus 3. This is our when x is less than 0. Okay, and what is going to be the same? This is equal to the function value. This should equal to the function value. Q minus 5 equal to what? 6, right? First limit is exist. So function value. Sorry, here is says f is continuous. Now let's use this one. F is continuous. F is continuous. Value of the function at 0 is this one, and limit value we got. What is the limit value we got? Either it could be exactly. Oh, sorry. Here is I'm making mistake. Now 6, not 6. So what is limit value? Either by the left limit or right limit. Anyone I can use and say that. So what is the limit value at 0? Just now I think many people got confused because of this glitching of the sign just wrote by this very congested form. What is the limit at
0 is equal to q minus 5.
So q minus 5. So what is that limit exactly?
We got the limit exactly 9.
Exactly 9. Yeah. Using the left or right, anyone you can use.
Equal to?
Yes, sir.
So p
9.
will be equal to 6. Can you explain the other things? Sir?
P is
P is equal to 6. What about the others, sir?
What are the others? Sorry?
No, sir. How did we find the value of x is equal to 0? Value of the function.
Here is this one, no? What is this?
Q minus 5.
So that's the root hierarchy. Q minus 5 value of the function is q minus 5. And what is the limit we got? What is the limit?
6 plus 3, 9 of this.
By this way, you can get right limit is because the function is continuous. Left limit and right limit, or even the limit exists. That means what? That means
it is continuous.
All the function have equal have same value.
Yes, same value should be. Means the limit value should be whatever the limit you will get, it will exactly the same. That means here is finally we got 9. So here is finally
Yes,
we got
sir.
q equal to, I think it will be 14.
Yes, 14.
Yes, it is going to be 14. So here is your function is actually this one. When x is less than 0, And when exactly at 0, this is going to be 40. And for R value, we'll try to get that. So here is, we are done. We are now, let's back to here. So P value is 6 we got. Q value is 14 we got. So here is finally, this is what? What is this one?
-6.
Minus 4h minus 6 we got. Okay. Now we want to find, we are trying to find the limit of when x, left limit or h is approaching to 0 from left and c are approaching to 0. What is, how we will find that? What is the limit here? How we will find the limit here?
Sir, can we directly differentiate both sides and put them equal?
Okay, from the both sides, yeah, we can do that also. We can do, but by the limit we are trying to do that. Whether using the limit, I am trying to do this. So we are here. How to find? How we will find the limit? I think we are correct. No, here is 14. Here is QE. We got 14. No, so 14. Oh, sorry. This we got 14. So here is 14 minus 5 is 9. There is 3 minus 9, which is 6. Here will be 6, no? Yes, here it will be 6. I just wrongly wrote. Here it will be 6. So how we will find this limit? Now let's talk about very quickly. We'll back to here and let's talk about indeterminate form and the L'Hopital rule. That is not a big, very small. What is the indeterminate form? Sorry, how to find? Yeah, so here he will try to find R, right? Here we actually didn't reach to the R right side. We are actually find the limit, right, left limit. So we reaches here, but how to find how we will find this limit? Anyone have idea how we will find this limit?
So we have to take
We got
each of the denominators.
L'Hopital's rule, sir.
6.
We cannot use because directly substitution will not very clear. So we have to go with the L'Hopital rule. So let's talk about the L'Hopital rule. Something is
Most of us know, sir, like because there is a big time.
So L'Hopital rule is, let's quickly revise that. L'Hopital rule work for the cases once you are trying to see similar cases happening. Once you are trying to find the limit and the limit case of the rational function, and it is happening like this: 0 by 0, or positive infinity by positive infinity, or negative infinity by negative infinity. Once you substitute here the h0, h is equal to 0, you are getting similar kind of thing. If it is this happening, okay, just derivate the function separately, numerator and denominator, and then find the limit. That is the L'Hopital rule. So here is just derivate the function. So here is what will be the derivative? It will be 6 e power h minus 4 upon, and in denominator it will become 1. That's why we actually revise using here, using this problem of L'Hopital rule also. Now substitute h0. This is going to be here.
We got 2, sir.
We got 2. So left limit or left derivative is finally 2 we got. There is left derivative is actually. Now let's find the right derivative. So right derivative is what? Limit h going to 0 plus h minus f of 0 upon h. So here is, this means that your actually h value is greater than 0. And when h value is greater than 0, our function is behaving like this. Let's do it. Here is, this function value is greater than 0. Here this could be written as h going to 0 positive. This is fh minus f of 0 upon h. So finally this is going to be r sine h plus 9 cos h minus function value is 14 we just now calculated here at 0, 14 upon H. Again, the same case. I think it is the same problem is here. We are trying to find the value of R. So how we will find, we want to find is this limit is exist. This limit is exist. What will happen then case? How we will find the R value? If you substitute here 0, so see that it is again the, what is the case happening? Indeterminate form, right? I think.
Sir, minus 5 by 0, that will be the answer here if we substitute 0.
Oh, minus 5 by 0. Okay, minus 5 by 0. So I think we are missing something. Then we are able to.
So I think we have to differentiate it.
We have to differentiate it.
No. So, but here is the not 0 by 0 form is happening. Oh? This is 0. This will become. This is minus.
Minus 14 by infinity form.
So but our L'Hopital rule apply only for this one. No? This and this.
Sir, I think we can do R sin H by H is equal to
14
R
minus 5, right? So it's 9, not 14.
cos H by H. Sin H by H
I think that's the here problem. I think we are missing something. Minus 5 is there, but how minus 5 is coming? I think you have, this is function value is this one. Here is 14 minus 5. No, here is not 14. Here we actually with Q value you get, no, 14 minus 5, which is 9 we have. Function value is 9. Oh, sorry. So here is 9, not 14. Q value we got 14. No, Q value we got 14. But function value is 14 minus 5, which is 9. That's the missing part we have. So here is actually 9. Now we can see it is in indeterminate form. Again, 0 by 0 form is happening. That previously here it were 14, then it is not indeterminate form. No? It is kind of minus 5 by 0. This is not our indeterminate form. We cannot apply here L'Hopital rule. Our rule is only for 0 by 0. And here is not positive and not negative. Both should be same. Positive, positive. Negative, negative. Okay, please remember this one. If it is not, then you cannot apply. Okay. So here is, this one is happening. 0 by 0 form is happening. Here is 9 will be. Again, just differentiate this function. So it will be what? Cos H R time minus this is, what is the derivative of cos? Become minus, derivative of cos is minus sin H, and this is upon H. Now just limit H goes to 0, positive. Now just substitute here. Oh, here it in denominator it will become 1. Separately you have to derivate. So here is now R, and it will come 0. So this is finally the limit is R, and left limit is 2 we already, sorry, left derivative already calculated. So finally R equal to 2 we got. So this problem is, many things we have discussed in this problem: limit, continuity, and differentiability all. So by this way, so some problem graphically can also be some problem there. Okay, it can graphically we can draw, and then the same problem, where is the function is continuous, differentiable. Okay, find the values of PQR. Graphically can be also asked. So see that this is the way. This is the way we always you have to find by this limit, and this is the way to checking differentiability. Now let's talk about, now once we have done with the differentiability, I have already listed out some derivative, the derivative of some function, a specific type of function. Now the last topic is remain the critical points. That is not L'Hopital rule just now we discussed. Now the critical point is there. So simply critical point or global maxima, local minima, very easily. So critical point is, what is the critical point? Means the points where we have some, where the points is something, some differently it is happening. That's why the name is also given the critical. So here is, let me write the graph is here. or even let me write the graph is one thing, and let me write the function itself. Fx is equal to mod of x minus 1 this is the function in here. This is the function if you have. Okay, this is one part. Or even let me add it here also, some more extra thing. X cube. Yeah, that would be good. In mod, this is we have. In mod, in multiplication, x cube is there. So what is going to be the graph of this one, this function? It will be more difficult, huh? But we can graph something we can graph. I don't know what is actually graph, but we can think it. And this problem will be give much clarity. Will give more clarity in the all critical points, maximum, minimum. So let me draw the graph here. If you remove x cube here, okay, if you remove x cube, okay, for the time being, I am just removing x1, x cube. Okay, so here is suppose 1, here is 2, here is 3, and here is 4. So this function you have, so at 1, 2, and 3, 4, the function value is going to be 0. That means, and if you remove mod also, for the time being, just remove the mod. Okay. So this is a polynomial of degree 4, correct? This is a polynomial of degree 4. And here is the roots, 1, 2, 3, 4. What is the yield behavior of this one?
X tends to infinity, y tends to infinity.
Yeah, it is a if it is a minus negative, then it is like this. And at 1, it will be linear. At 2, it will be linear. So like this, it will go. I think so. Or maybe. No,
it will be opposite side.
It will be opposite as like this. Okay, this is the, and now let's put here mod. Okay, let's put here mod. That means you will always get the positive value. Positive value means whatever the negative value is. This is the positive thing. This is the positive thing. Only these values in this interval you are getting negative value. So just reverse it. Just reverse it. Let me reverse it here. So okay, I just this one. Okay. This one. This one. So just reverse it. Where is it is negative getting? That is going to be positive. Okay. This is the going to be now graph for this, at least this one. Okay. For this one, this is the graph. Now see, here is the critical point, means here is the points where function has something different. Okay. So these points is actually where the function have some local maximum, minima. So here it is. See, the local maximum means whatever the value you are getting here, that is greater than this value. But local maximum means around, suppose at here it is being got this one. So around this one, the value is actually this one. So local means locally. This is the local values, and these are the local values. Around this one, you are getting this local value. Okay. So this is the local maxima. This is a local maxima. This is a local maxima. Okay. This is the local minima. Okay. Around the around some values here, around this values, this is this value is lesser than around whatever you have. This is a local minima. This is the local minima. Okay. Now we have to note something that now all of you have aware with the very much that mod function is not differential. Many times in all of the sessions, mod function is not differentiable. The reason is it is a sharp corner. Why it is sharp corner is there? We can easily check that. If it is greater than 0, it is positive, and if it is less than 0, also get the positive value. That's why it is or even the mod function is exactly this one, x minus x. So this is the line, right?
Slope is not possible at that.
So yeah, that's the problem here. Slope is not
Odd means
possible.
if it is odd, it crosses the line, right?
Sorry.
If the power is odd, in the graph the curve crosses the x-axis, right?
If it is not mod, no?
No, sir. Like for x minus. Okay, sir, got it.
So here is what is happening. Here is also the same things. This mod can be think like this also.
But sir, if mod is not there, x minus 1, x minus 2, x minus 3, x minus 4 will cross the x-axis, right?
Yes. So previously, that's why I just discussed. No, I think you are not there. So this is separately deal. So here is, that's why it is a kind of same thing. It is happening. So this is a sharp corner is actually happening. So these are the point where function is not differentiable. So critical point. Let me write now the critical point. So critical point is. So if, and also let me check that here is, if you find the derivative, or once you find the derivative value at here, so it will be 0. The reason is, so if you see that slope here is derivative value is actually the slope. That is if you at that point. So here if you check that slope is actually 0. The reason is it will be parallel to x-axis. So how we'll find the critical point means just derivate the function and equate to 0. Equate to 0 and find the value of it. That is going to be the critical points.
So please
this
repeat
is one
please.
thing. The word is here. If you want to find the critical point, the reason why it is equate to 0, the simple reason is this one. See what is happening what is happening at the local maxima. Slope is what is happening, that tangent line at 0 is parallel to x-axis. If it is parallel to x-axis means the slope will be 0. That's why if you want to find the critical points, the reason is also you can give why it is equal to 0 is, this is the reason. And also this one we can check. We'll check with the difference, because here the function is not differentiable. We'll later discuss. So if you want to find the critical points, so then derivate the function and equate to 0. So simply, for example, I am giving, just suppose you have a function sin x. Okay, sorry, you have a function f(x), which is x minus 1, x minus 2. That means here it will be x square minus 3x plus 2. What are the critical points it has? Just derivate the function. If you derivate this function, this is going to be 2x minus 3 and equate to 0. That means x is equal to, at 3 by 2, it have critical points. This is the process to find the critical point. So equate to, just find the derivative of the function and equate to 0 and find the values of x. This will give the critical point. This is one. And another is where the function is not, differentiable. So here is where the function is not differentiable, these points are there. The simple reason is, by this way you can think. And already we know that mod is not differentiable at 0. So similarly at -1, at 1, at 2, at 3, at 4, it is not going to be differentiable, because here is going to be very sharp. If you see the graph, here is smoothly some kind of looking, but it is actually a kind of very sharp as the mod at 0. Mod at x is simply could be written as mod at 0 kind of thing, right? The same thing. At 0, it is very sharply, it is behaving. Very similarly, this is also very sharp. Sorry, yes.
How many critical points are there, sir, in this graph?
So how many critical points? So that's the thing here. So here is 4 points are there where the function is not differentiable. So this point is also critical point. So to find the critical points, you have to equate to 0. How many values you are getting, that is a critical point. And also you have to check where the function is not differentiable. Suppose I don't know, it is a similar kind of thing is happening. There is a break also. After
s-
this one, there is a break. So here is
voice.
also function is not differentiable, right? Sorry. My voice is breaking.
Yes, sir. Yes, sir. Can you please repeat what you just said?
I'm saying, suppose at here, let's say this is, I don't know what is that at 100. At 100, this is the function we have. I just added some function also in the here. So I don't know what is that, but I just assume that the graph is like this. There is a break. There is a break is also happening. So at break, you know that it is not continuous, even the limit is not exist. There, function is not differentiable. So this is also a critical point if you think if it is there is a break. But for the time being, we are dealing with this function, so we are not going to discuss. So we can remove. Otherwise, if it is there is a break, that is also a critical point. Not kind of, that is also a critical point. So where function is not differentiable, that those are also critical points. So this function have how many critical points?
Function is not
2,
differentiable means the slope is 0, right?
no, function is not differentiable means also the case is left derivative and right derivative not same.
Yes, sir, got it.
Okay. So here is this one. So here is 1, 2, 3, 4, 5, 6, 7 critical points are there. Okay. 7 critical points this function. Okay. So now once you have a critical point, so there is a test. There is a test.
So we are
Test
critical
is
point.
that. Sorry. Could you repeat, please?
So critical points, we are taking the ones that are not differentiable and like the points like points x-2 and all, and the ones like that are like local maxima and minima.
Local maxima and minima. So, but how we will find? So there are two conditions. Derivate the function equal to 0 and find the values of x. There, those points are actually critical point, and also where the function is not differentiable, that point is also a critical point.
All right, understood.
So
Thank you, sir.
okay, so collect all critical points. Once you have collected all critical points by these two way, either this way or this way. No, not either this way, by this way and by this way. Okay, collect all critical points. Once you collected that, so test will help only for this one. Okay, the test is only help for this one. This for the f double prime. Because where the function is not differentiable, then how the second derivative test will do? So the test is only for this one. And for this one, we have two graphs. So this problem will not generally ask. Okay, this problem will not ask, but generally this will be enough to deal with that. Okay, so test is actually what? Test is that just derivate the second time. Okay? And if it is greater than 0 at A is a critical point. Suppose A is a critical point. So at A it is greater than 0. Then A will be a local minima. Okay? And if it is double derivative at A value, double derivative value at A is less than 0, then A is a local maxima. Okay? Two tests we have. Okay, and saddle point is what? How we'll check the saddle point is? Saddle point is actually just derivate. Okay, derivate the function at A, and at A it will be 0. Okay, at A it will be 0, and think about the left side of A, and if it is still left side of A is greater than 0, right side of A is still greater than 0, or left side is still less than 0, greater side, right side is also less than 0, in both cases is going to be saddle. That is not a big deal. Okay, that is, you have to check that with the analyzing. You have to, means only the left derivative, only one derivative, and check with these two conditions. If it is happening, then that is going to be a saddle point, like x cube. Suppose you have a function fx is equal to x cube. See that how it is happening. This. Now what is happening? See that at 0, around 0. Okay, just derivate this function f prime. It will be x square, 3x square. So 0 around 0 means here is around 0 means I said a minus h. This is around 0 left side. So means 0 minus h. Just derivate and find the value. It will be f prime minus h. What is going to be 3 h square, which is greater than 0. Right side 0 plus h, derivate value. This is going to be f prime h. This is what 3 h square. Again, it is a greater than 0. So that's why it is going to be a Z. By this way, you can check. Or either it could be the same by this, like minus x cube. Is fx is equal to minus x cube is there. Then this case will arise. But it still will be the same. The saddle point. 0 is the saddle point.
What is the meaning of the point of inflection?
So that's the meaning of point of inflection, no?
Saddle point is a point of inflection.
But inflection and inflation, yeah.
Okay.
Yes. So here is the same thing, is it? Week 9 to 12 we discuss in the next session. Not 9, 10, 10 and 11.
Sir, can you scroll down a little? Sir, I want to see a graph.
Okay.
Sir, local minima is always below the y-axis, isn't it, sir?
Not necessary. Not necessary. Not necessary.
Oh.
Suppose your graphics like this. So this is also a local minima, no? Okay. So this is the process. This is the process, and this is the way to know local maxima and minima. So let's solve the problem. Suppose I am just giving a function. Yes.
Sir, how long is this class for? Sorry to ask this question.
So now almost we have finished this. So either it could be solved problem, or the last topic, which is the Riemann and integral. That is not a big deal, no? That Riemann is. Let me discuss the Riemann is.
So can you just explain the concepts, because college.
Yeah. So okay. So Riemann sum is what? Riemann sum is. I have taken on the Riemann sum session, and very well I explained what is the Riemann, why the reason is Riemann sum is there. Very quickly we can see that suppose you have a graph of a function. This is the graph if you have, and I want to find the area under this curve. Okay, I want to find the area. What is going to be area under this curve? Suppose here is A and here is B. So what is this area going to be? I want to find that. So to find this area, what we can do? We can just break. Okay, we can just break it. We have just break it. I have just break down. So see, the problem is, see, this is a curve thing. Then it will be difficult. It will be difficult to find this area. So what we can do? We can do some increment and find this area. This could be easily find, right? This area could be found because this is now a rectangle. And suppose we just break this. So this is interval A. This is interval A to B. This is our real line, interval A to B. Okay. So this is, we break our whole interval in some part. We break down our interval in some part. That is called partition. That is called partition. We are doing partition of this interval. Okay. Now, what is going to be? Suppose this is H. This is what is this? This distance is S. This is going to be A plus H. So what is the area of this rectangle? Can you tell me what is the area? Suppose this function is f of x.
Would be the integral of everything to A to B.
Sorry, what is the area of this rectangle?
Integral of A to A plus H f of x dx.
That's fine. That is fine. That is one part.
Integration of that point A plus H.
No.
And the
So
delta
that is not, that is the function for this one. This will give area till here only. But I am asking what is the area of this rectangle? What is the area of this rectangle?
H into function of value of function that point.
Yeah, H into value of the function. This is the right.
Point.
Similarly for each one. Similarly for each one. Similarly, find that this length and this, sorry, this width and this length. This width and this length. This width and this length. So by this way, you can find the area. But the problem is some more area is added. Here is some more area. Okay. Here is some more area is covering.
This is overestimation.
So this is overestimation is happening. So this is actually what is happening here. This is the, if you take with this area sum, this sum, this is this sum. You see that this is right side I am taking. No, this is each time. This is A plus H value we are taking. So this is called, now if you sum them, if you sum up them all, if you let's say this is xi. This is, sorry, this is x1. This is x2. This is x3. This is x4. This is x5. Okay. So in place of A plus H, we can write x1 right here. So if you sum them all area, this is called right sum. So please, my suggestion is when we are discussing this right sum, left sum, Riemann sum, my suggestion is, because of in 2 hours we have already discussed a lot more on the Riemann sum. Please watch the Riemann sum session. Very, I took at least 1 hour and to discuss that, I think, for the Riemann. And the same way, with the same way I discuss. But this is a revision session, so I am just quickly revising. Otherwise, my suggestion, if you want to see the revision, that is Riemann sum, same way I explained. And if you want, I can give you the link of the video. Just a minute. Let me search.
Sir.
Sorry?
Excuse me, sir. Can you explain 2 questions from the mock test that we were given and it was for Riemann sum, sir? Can you explain 2 questions?
Yes. Let me, yeah, that would be good. So, okay. So just a minute. Let me open that video itself first. So this is August. So I forgot to ask how the TA session is going. Is that good? Fine.
Very excellent, sir. This is very helpful for us.
Okay.
So apart from all television lectures, it is nicer when we're doing it live. So it's very good.
But only one problem, sir. Many of the sessions are at the same time. We cannot do both sessions at the time.
So I also have a problem, sir. I cannot join the sessions that are conducted at 11 and 3, so 11 a.m. and 3 p.m. So others I can join.
No, there is no timing for the 11 for maths. For other courses, if it is, then I don't know. For maths, there is no issue, I think so.
All right, sir.
Sir, can you do something then 2 sessions at a time?
2 sessions at a time. I don't like that. Okay, just a minute. Let me just checking with the.
So will you be taking anything else?
Sorry.
So will you be taking anything else?
Okay, I think it will take time to search. Please search and where is the Riemann? I think on week 9 it is, no? So on week 9 we can find, this is week 10, no? This is week 10. System 7
Sir, how long will
7
class run?
9. So now it is almost done. So it is almost done. So this is the Riemann sum. So I will let me solve a problem on the Riemann. Okay. This is, please keep 10 minutes more. Okay. Where is that
Okay,
Riemann?
sir.
Where is that mock? Even I have listed the mock the Riemann sum problem is there. Okay. So what is that? Choose the set of correct estimating area region bounded by the graph of the function f in the interval. Where is that graph? The 11 and 12. Okay, this one. For this one. 2 to 0 3. Sorry, 0 to 3 using the Riemann sum. Estimated area will be 0 to 0 unit by taking 3. Okay, but still the mock is deadline is there, no? Mock is not over. So I have some problem. Let me discuss that Riemann. Okay, this one I have. This one. Let me finish this one. And also see, I did not finish this problem. It is finding the critical points there. Am I audible?
Yes, sir, you are
Yes, sir.
audible.
Still you are on mute.
Yeah, okay. So see that this problem I have just wrote. So let me write. So we have this problem. No, this is a maybe in the. I'm suggesting you very similar. You may get in the exam. Okay. So maybe here is Riemann. It is given, but maybe integration sign will be there. Very similar question will be. So what is going to be the estimated area region bounded by the function above 0 to 10? 0 to 10 using Riemann sum obtained by taking 5 subinterval of equal length midpoint. So see that this is for midpoint intervals, okay, for the height of the rectangles. So midpoint, using the midpoint, what will be that? So here is first 0 to, sorry, it is saying 0 to 10.
So
And we
what
have
is the answer of this question?
I don't know. I have to check it.
Oh.
So let's find the Riemann sum for this one. So
Okay,
here is
sir.
we have to break our interval in 5 subintervals. So what is going to be the once you break interval? What is going to be the intervals? If you break this in 0 to 5, 0 to 10 interval.
0 to 2, 2 to 4, 4 to 6, 6 to 8, and 8 to 10.
Yes, this is will be right. Eight to 10.
Yes.
These are the 5 subintervals. Now says equal length and the midpoint for midpoint of the subinterval. Midpoint. What is the midpoint of this interval?
1, 3, 5.
1, 3, 5, 7, 9.
Okay. Okay. So okay. Now for the height of the rectangle. So midpoint uses for the height of the rectangle. Here is what we discussed. Left side.
Yes, sir.
Sorry, right side. But here it says midpoint. These are the midpoint. Okay, these are the midpoint. So what is going to be now sum of that? Right? This is f of, sorry, what is going to be sum? What is the now width? What is the width here?
2.
For each interval? 2.
With this
2
two.
f of 1 plus 2 f of 3 plus 2 f of 5 plus 2 f of 7. 1, 3, 5, 7 plus 2 f of 9, right? This is the area. This is the area. This is the area of
Yes.
rectangle.
Yes, sir.
Now, what is that? 2 into what is f1? Where will be f1?
Sir, first equation, sir.
The first one. This is 1 square plus 6 plus 2. Well, what is f3? What is going to be f3?
Second equation, sir.
Second equation, right? Because 3 is here. So that's why this will into 2x, sorry, in place of x, it will be 2 cube plus 6. Okay.
Rest
Now,
of the use third equation.
third equation, because after 4 it is. So this is going to
Yes,
be
sir.
5 plus 1. 2, 7 plus 1. 2 into 9 plus 1. Now sum it. This is going to be answer. That's all. This is the midpoint. This is the Riemann sum. And my problem is, again, I am just a bit. So my problem is so this problem is here. What is going to be this integral? What is going to be this one? How we will find this one? Or the simple problem is find the area under this interval. That's all. Now, if you answer this one, I am just going to close the session also, because this is the last one problem. How we will solve this one?
Sir, we'll break it from
Yes, sir,
0 to 2,
Yes.
then 2 to 4, and 4
We
to
have
10.
to break.
4 to 10.
We have to break
Yes, sir.
because our function, because their
Function is
function is
breaking.
actually breaked in the, it is in the breaked form. So we have to according to that. The breaks are actually at 2, at 4. Okay, so that means here is 0 to 2 fx plus 2 to 4 fx. Here is dx plus 4 to 10 fx. We have breakdown our function. Now 0 to 2 our function is behaving like this. So here is this is going to be 0 to 2 x square plus 6 dx. This is 2 to 4. Our function is 2 between 2 to 4 behaving like this. So 2 times x minus 2 q plus 6. When 4 to 10, it is going to be behaving like this. So x plus 1, 4 to 10 dx. Now
4
find
to
each
6 we are
integration.
not taking.
Sorry.
4 to
Why?
6.
4 to 6.
Yes, sir.
4 to 6 or 6. 4 to 6 is, there is no break, no? 4 to 6 is exactly same. This, oh, maybe you got confused because of this one. So this is for Riemann only, but our function is smoothly behaving in between. There is a problem at 2 and 4. So where is the problem? We break down that, and in between it, the function is smoothly behaving. Yes.
Small doubt, sir.
Mm-hmm.
For first case,
Mm-hmm.
0 to 2,
Mm.
but that function is for less than 2, sir. Is it?
So less than, so here is, let me tell you. So this is the limit. This is not value. So that's the, let me tell you. So in integration, here is a, b is written. These are the limits. Means here is not you are talking exactly. That means here is, you can think x approaching to a, x approaching to b. That's the meaning here. Okay. That's why it is like this. So it is the value not exactly a and b. It is around a. Here is around a. That's why it will work. Okay. So these are actually limit value. In different word, this is called limit values. Here is written limit values.
Okay.
Okay.
Sure.
So by this way, now you can just integrate. So let me write the integration formula for x to the power n, integration will be what? X to the power n plus 1 plus 1. Integration of cos x is
X
minus sin
square
x.
by 2 plus x.
So yeah, it will be the same way. Now I'm just writing, I'm just leaving this portion because this you need to know at least, because I'm just writing this formula, using that you can find. And this is integration of sin x is what? I think I made a mistake. The cos x is exactly sin x. Integration of sin x is minus cos x, no?
Yes, sir.
Yes.
And integration of integration of e power x exactly. Integration of 1 by x is exactly log x. So here is ln x, and here is plus c is there each time. Y plus c is there. This c is actually constant, and this constant means if you differentiate this, you will get exactly this inside one, inner one.
This is
You know the
indefinite
constant.
integral.
This is indefinite integral.
Yes, sir.
And integration of 1 by dx and another are also, please remember that other. I just wrote for the specific one.
Sir, what will be the
integration of
integration of
constant.
ln x?
Integration of ln x. So this one is now you have to because what is the derivative of the reversible form of the, how you will derivate, then you will get ln x. There is no way, right?
Yes.
Then you have to, have to deal with some more information is needed. So that is, you have to break down, or what is that? How we will get this integration? Anyone?
No idea, sir.
Oh, sir, which one, sir?
This integration of ln x.
Sir, we have to do it by parts, sir.
So then we have to do by parts. So I think that is not taught in this lecture, no? Or only just integration is given. Otherwise, there is one way to solve, no? Integrate, then minus integrate of, you can assume it here 1, integrate 1 dx minus differentiate the second one. I think that is not taught. That's why don't worry, the such problem will not ask. Okay, differentiate the ln x and then integrate 1 dx. So I think this is not taught in the lecture. So don't worry with that. Okay, so using that you can.
If such question given, then hint is also.
No. Yeah, hint will be given, or it will not ask. If it is, it will not ask. Such problem will not ask.
The problems in the mock test for even some, sir.
So in the problem, Riemann mock is I'm just skipping, and I chooses this one because the mock have some deadline. No? So on 31st we can discuss once the solution will be also released.
Could you please
Tomorrow is the
repeat
last date.
this Riemann sums step by steps?
Excuse me, sir, but the answers are already given in the portal, sir. Like there is a deadline. I don't know if there's a deadline, but the answers are already given. It's like activity questions, sir.
Okay, we'll discuss that. Okay. So somebody is asking stepwise means stepwise I did, no? I first find the sub interval, then midpoint.
Sir means repeat other questions are asked. So which type of steps we take to?
Same. If suppose the same problem is there, in place of midpoint, suppose set left point. So in that case, what you will take? Suppose here in place similar, very similar. Either it would be 5 or 10 or 10, 12. Sorry, if it is suppose I want to divide my interval in 10 sub interval. I just changed this. The same problem. Okay, I divided. Suppose I have changed the problem and said I found or find or divide the interval in 10 sub intervals. So what is going to be that intervals? This one, right?
Yes.
0, 1, 1, 2, 2, 3, 3, 4, 5, 4, 5. So these are the 10 intervals, right? These are going to be 9, 10. If you count those all, it will be 10 intervals. Correct?
Yes, sir.
And now in place of midpoint, suppose left point is asked. So left point of the intervals. Here is midpoint, no? So here is left point of the subinterval. So left point of the subinterval is what? This one, right?
0, 1.
0, 1, 2, 3. Now that's all. What is going to be now? Riemann sum. Riemann sum is 2 into f0 plus, sorry, here is what is the length is here? Each 1, right? There is not 2, in place of 2 it will be 1.
Yes,
right?
sir.
Now 1 into f0, 1 into f1 plus 1 into f2, 1 into f9, till 9 it will go. Now finally find the sum. What is going to be sum? Similarly, in the left, right will be given. So in place of left, you will take right one. 1, 2, 3, 10. And the same width is there. So 1 into f1, 2 into f2, like this, 1 into f10. That is going to be right Riemann sum, left Riemann sum, mid
Yes.
Riemann sum.
Then integrate.
That's all. Is this clear?
Yes.
No, I think not for all. Maybe somebody
Yes,
helped
sir.
out. Okay, so slowly, and also please watch the Riemann session sum. Okay, and also I have explained with the example also with this one Riemann. And this one, okay, this part is okay, but I am suggesting you please go with this one also, because you may get exactly similar problem with this integration in the bracket form. Like the question will be here, it is like this, and what is going to be integration. Okay, so be clear with that and try to solve such similar problem you may get in the intern exam. Okay, very less chance to come the Riemann, very high chance to come with this one. Okay, this integration.
By integration, we have to solve this.
By integration.
Okay, sir.
Okay, so this is for the today's session. That's all. And I hope I have covered all topics: integration, area under the curve, Riemann, limit, continuity, differentiability.
Sir, can you solve the test question, sir? It's the answers are already given in the paper, sir. So I don't think there's any point in waiting, sir.
No, so then why the problem is like I think I have just discussed this. Then I think you are not getting the answer. That's why you are asking.
Oh,
This
yes,
is
sir.
the
Yes.
pro-
Yes, sir.
So then are you getting the concept? Are you getting the concepts?
I've understood the concept of Riemann sum, sir, but I do not understand this question, sir. These questions, like
This
why-
problem is okay. This problem is here is the function is given. Okay, function is given, and here is the estimated area 0 square unit by taking three
sir,
subintervals. Sorry.
So I did not see the functions over there.
Sorry, which problem?
I did not see the function there. I did not know it was a continued question, sir. So okay, sir. Okay.
This one.
Yes, sir. Yes, sir. I'll try again, sir. I'll try again. Number 12, sir.
So I think you missed that. Okay, for which problem is asked? Okay.
And 14, sir. And 14, sir. I did not understand 14 also. So question number 14.
So 14 is again, you have to use this one, no? Again, this Riemann is there, no? Riemann problem is there, okay.
Yes, it's Riemann and the idea of
If
maximum and minimum.
fx as local maximum at A, then the value of the left Riemann sum if the partition subinterval is equal to 5/8. If fx, okay, fx as local minima at x is equal to, what is fx? Capital Fx is this one. So here is, you have to first integrate. What is going to be integration here? That is going to be f of x, right? So you have to integrate f of t dt. What is f of t dt? This one. In place of t, you can x. In place of x, you can write t. And now integrate and then substitute the values -1 and x. That would be the function fx.
Oh, okay, sir. I think I get it, sir. Okay, sir. I did not understand what T was. I'll try it then, sir. I'll try it. All right, sir.
Okay.
That was my question, sir. Thank you, sir.
Okay. See, this mock is, I will say, tougher. Interim is not going to be much tougher. Okay. I'm just looking the mock. So don't worry. Okay. Ivan have
Multiple select questions will come in interim.
Multiple select also. You can skip my suggestion. You can skip the Riemann even. Just focus on the integration. Okay, Riemann problems are not very less chance to come in Riemann. So we focus on the integration. So don't worry the Riemann.
Sir, what will be taught in the math 2?
Linear algebra, linear transformation, vector space.
Okay, sir.
And then also multivariable calculus.
Sure.
Okay.
Thank you.
Okay, so thank you so much. That's all from my side for this second revision session. We'll meet the next revision session on 31st, which is on the graph theory.
Okay, sir.
Thank you so much. Good night to all of you.
Good night, sir.
Yeah, net type also will get. Yeah, net type question will also not much, but yeah, maybe easy question, but not tougher. Interim is not tough. Just if you bit know with the concept all the weeks, that was good. Like Riemann, you can skip. In the graph theory, we'll discussing the graph, we can tell you which type of question you get. And okay, we'll discuss when the graph theory will come. We'll discuss which topic will be more
Graph is a more weightage covering.
Graph have some more weight because graph we don't have pitches. Graph and this maximum minimum critical point, because week 9 is still remain for, because week 9 and 10, 11, 12 is not covered in the pages. Okay, in the last revision session we'll discuss more about the internal. Thank you so much.
Correct,
sir. So one mail will come. I got one mail. In that today is the deadline of week 11, it is saying.
No, 30th is that tomorrow.
Yes, sir. But in mail today they wrote.
No, for me it is also showing, so don't worry.
Okay, sir.
Let me check in front of you itself.
Sir, in week 12 there is no graded assignment.
There is no graded. Week 12 is there is no, just revising the concepts.
Okay.
Okay, so week 11 12 have deadline. For me it's showing the same, so I hope for all of you it is the same. So 30th is the 30th. Tomorrow is the deadline.
Yes, sir.
Thank you so much. Good night to all of you.
Thank you, sir.